How do I know which one is which one? Now, I want to go to another major area that will be in the final. Okay, another major area is factor analysis. Factor analysis. In factor analysis, you need computation, maybe with calculator. Okay, and take a look at this. Analysis has already been conducted, and you got so many variables, right? I think I can see eight variables, and they've already choosing 3 factors. Factor 1, factor 2, factor 3, and you can see the loadings of the features on each factor. Can we now see the way the question is going to look? Oh my God. The first question said, using the estimated factor loadings, okay, determine the specific variances and commonality for the first 6 variables and interpret your results. Take a look at that. How do I compute specific variances? How do I compute commonalities for the forces? Okay, and another question said, using the estimated factor loading, determine the proportion of the total sample variance due to the first factor. Let's take a look at how do we compute commonalities and, specific variances. Please pay attention. It's easy. I'm going to go into the first variable. What am I just going to be doing? Here, I'm going to be squaring. Oh, this final is so easy. It's going to be so easy. See this one? All what I just need to do, okay, is to square that. Oh, sorry. I want to do that for, if you take it for each, I think they said for the first 6. So I'm going to do something now. He said for the first 6, then I'm just going to be squaring that. Now, I need you to pay attention to what I did here. Now, you can see for the historical return on assets. So what I did is this. I'm just going to take on the first one. I'm going to take on this one. I will square 0.43, square 0.61, square 0.50. Whatever I got is the commonality. Commonality means shared variance. Okay, I will do the same, for the remaining one, but I think it's restricting you to the first 6. Now, which means that's a calculator work, which is what I'm doing here. Can you see what I'm doing here? Just squaring them, they get a result. But you know what? The moment I get the commonality, specific variance is going to be easy because commonality and specific variance are mutually exclusive. I will subtract whatever I got from commonality from 1 to get the specific variance, so I'm going to do that. This is my table for the first 6 that they mentioned. Commonality, specific variance, you know what? They must add up to 1. Okay? Commonality and specific variance are mutually exclusive when you look at the model. And it also talks about interpretation. I said most variables have high commonality, as you can see. You can see the commonality, which means the share variance is very high. Okay, all of this is greater than 0.8. You can see that. And what does that mean? That indicates that the 3-factor model that we use explain the large portion of the variance. The threshold that I'm using now is at least 80%. Can you see that? And I said the specific variance are low, showing minimal, unique, or unexplained. The specific variance means a unique variance or the one that is explain. The shear variance is like the explain. And another question said, what is the proportion of the total sample variance explained by factor 1? Okay, I need you to pay attention. Factor 1 loading. I'm only going to focus on the sum of square of that factor. Now, you can see here, I was doing 0.43 squared up to 0.91 squared. Okay, where did oh my God. Where do I see that? You're actually going to see here, please pay attention. You see it's 0.43, 0.13. I'm going to go to factor 1 now. Do you see this guy? Which is going to be here. This time around, I want to know the contribution of a particular factor. If I want to know the contribution of a particular factor, I will do the sum of squared loading, okay, under that particular factor, which is 0.43 squared plus 0.13 squared. You can see that's a lot of calculator work. That day you are just going to be hearing. Make sure you use a calculator you can trust, okay? You know what is coming already, okay? But you need to have enough practice. Now, look at what I did at the end of the day. After that, what is the next thing I did? I got 2.3018. Okay. But how many variables do I have? How many features do I have? It's 8. I wanted to go back to the question. How many do I have? This one is 8 of them. I will divide by 8. When I divide by 8, okay, what is going to happen? Divided by 8, I got that. Then it means the factor 1, the total variance explained by factor 1 is 28.8%. That's just for factor 1. You can ask it for factor 2. You can ask it for factor 3. Now, I'm going to tell you. Now, let me tell you this. The final practice that I'm showing today, if you study only this final practice, and probably you are committed and kind of you pay more attention to detail, you should score at least 93% in this exam. Now, but I'm not going to deceive you. Problem 4 will be challenging, and I need you to pay attention. It's on canonical correlation. But you know what? Some people can decide to use calculator. Some can decide to use arrow code. I provided an arrow code for this problem too. You see the arrow code here? You see the arrow code? That is the arrow code. Is a question like this coming? Oh my God. The question like this is going to come. Of course, I'm going to change numbers. It's not going to be those numbers, but it's going to come like that. Now, let's pay attention to this. This is a question on canonical correlation. Now, you can see what you have. I told you in the canonical correlation, you're actually going to have two sets of variables, right? Two sets of variables, they're going to have their own, You can see the mean, the joint mean vector. And see the way the covariance is partitioned. You're given a question. Oh my God. Because I have 4 questions, each question is going to worth 25 points. 25 times 4 is 100 points. Now, it said calculate the canonical correlation. Determine the canonical covariant pair, this and that. I want us to pay attention. Okay. If you want to just this is what I expect you to do. You see what did I do to get this? Oh my God. When you take a look at this, that is for this guy. Find the inverse of that. Find the inverse of this one. Find the inverse of this one. Find the inverse of that one. We've done matrix inverse in this class. And after getting the inverse, after finding the inverse, please pay attention. After finding the inverse, I got this 4. Very easy. Getting inverse. And after the inverse, okay, because getting this correctly done depends on how you're able to get the inverse. Now, the next thing I'm going to do is, because the R squared, they are the eigenvalues of this guy. The eigenvalues of that. And you know what? I've already gotten each of that to be the, look at this guy, look at the inverse, and look at the 1 raised to the power minus half. Take a look at that. Now, that's now give me this. Okay. And if I have that now, what is the next to do? This means if you look at what you have here, please pay attention. If you take a look at this one, I have that. Now the eigenvalues are this, which correspond to the eigenvectors given at, and finally, I got this guy. But you know what? If I were you, if you do, because of time flies in exam, I would just come here to the data here. Of course, I'm going to allow cheat sheet. Look at this. You see that mu1, I put it, mu2, x11, I just put it. And the moment you put that, just copy this into your R, you're going to see final result for A, final result for B. The arrow code, these are the arrow code. The only thing you just need, but if I were you, why can't you run this code and see whether you're going to have the final result? Now, at the end of the day, the result that you're going to write, then you're going to write it in a, you can see for UV1, U1, V1, V2, V2. All of this will be on the final. Particularly, the way it appears for problem 4 is the same way that is going to appear. But of course, I'm not going to say -3, -2, 0, 1 again. I'm going to change those values. Those are the questions that are called, the areas from which your questions are coming in the exam. This is being recorded. And of course, I also want to say this. I've already shared, what is it called? The deadline for submission of the project. Okay, I think I said that for, you can check the Canvas for that. So, this junction, I'm going to say, it has been a privilege for me to be your professor this semester. And let me tell you this. I remember, I'm going to just share my personal experience with you. I've passed through this stage before. And I remember when I was doing my bachelor program, I remember when I was doing my master's, and I remember when I was doing my PhD. Even though there are some kind of difficulties that I encounter, but there's something that normally keep me going, because before difficulty comes, I know they're gonna come. Why? How do I know they're gonna come? Even though I don't pray they should come, but I know we live in a stochastic environment where the world is statistical. I don't expect the same thing to happen in different days. I know different things happen. So when things happen, I don't allow it to overwhelm me. God is okay, you're difficult right now, but I'm just going to take my time. I'll figure you out. So what I would advise that you should do is, it doesn't matter whether you don't have A in midterm 1 or you don't have A. in midterm too. But having A in final is very, very essential to having A in the course. Because what I'm going to, what is going to make me happy at the end of the day is, wait, now, what is it going to take from me? If everyone in this class has A's, it's not going to take anything from me. It's only going to add to my joy. And what I need you to do is just take your time. I've given you the areas. The final is coming. Come to the final with the belief that you're actually going to succeed. Let me tell you this. The condition of, the condition that we study in Africa is very, very complicated compared to this part of the world. I remember in 2014, why I think I was still doing my PhD, but it was getting to an advanced stage, and there was I think Association of Commonwealth University call for research grant application from the Commonwealth nations, and initially I do know, I saw the call and I waved it aside because I didn't believe you know I stood a chance. You know, there are situations in life, there are times in life, there are moments in life where self-doubt whisper louder than qualification. But somebody that is very dear to me, my wife, said, you know, oh, Kazim, you've done your job. Let's nature, let God do the rest. And I yielded to the advice. I applied. You know, that very year they took 50,000 applicants around the world, but I was one of the 40 people, 40 recipients of this award. And that award took me from Nigeria. Has anybody heard about a country called Nigeria, right? In Africa, yeah. And that took me to, uh, you know, that put me on academic limelight because I had the opportunity to present my PhD work with one of the most prestigious university in the world, University of Oxford in the United Kingdom. That was in 2015. So you can see I did that because of the power of belief in me. And make sure you also, if you ask somebody, we have some people in life that when your leg are too tired to move, and maybe they give you advice, they encourage you, listen to them. And let me also say this, even if the whole world, I used to tell my children, my 5 girls, I said, you know what? One day my child called from school and said, oh, somebody said I don't look beautiful. I said, sit down. Because the person know you are beautiful, and that's why he said you are not beautiful. So whatever they say does not define you. You know within yourself you're beautiful. I said, and she now said, what am I going to say next time if the person say I'm not beautiful? I said, tell the person, thank you, but I'm beautiful. Then walk away. Now, even if the whole world don't believe in your ability, but do you know the whole world is going to succeed only if somebody join them? Who? You, when you join them. If somebody, if the whole world say, oh, you can't do anything. You don't have that ability. But if you don't join them, then you can show them you have the ability. So don't let whatever anybody say get to you. No, no, no. Just face what you're doing. Oh, what do I need to do in this exam? I think professor said we should do there's gonna be number one, there's gonna be question on LDA, KDA classification. Oh, the second question is on principal component analysis. Oh, I don't need to use R, it's just interpretation. The third question is on factor analysis. No R, I should only know how to compute commonality, all of blah, blah, blah with my calculator. But number 4 problem, oh, that may involve using R. The moment you just take your time. I used to tell people around me, failure in life, um, it's not falling down, but staying down. And how do I see success? I see success as ability to rise after many falls. When I've fallen before, I pick myself up. When you fall, pick yourself up. Even though I don't pray for you to fall. But we live in a statistical world where there's variation. It could happen, somebody fall. Pick yourself up when you fall. So when you pick yourself up, I'm referring to that as a success. They are not what you have achieved, but the ability to rise after many falls. But what is failure? Failure is inability to rise. You fall and you don't want to pick yourself up. Believe in yourself, even if society, in fact, even if the whole world don't believe in you, believe in yourself. Believe I can do it. Believe you can actually do it. There is nothing, when you look on paper, difficulty is if you go to the dictionary, you see difficulty. I know difficulty exists, but when it comes on my door knocking, I'm gonna say, difficulty, welcome, but I'm gonna figure you out. So I'm wishing you the best. Come to my exam with the mind that you're actually going to succeed. I wish you the best of luck. See you on the day of examination. Bye for now, everyone. Thank you.